All right, now this is where it's going to get really fun. They are difficult calculations. So hopefully you understood the difference between an aliquot and a dilution, and we can move on to the calculations now. So aliquots and dilutions are basically two ways in which we manipulate the known and the unknown, and they need to be included in our calculation. All right, so we're going to do example number 4 now, and I've just realized that this one's an easy example, so I'm going to move on to this one, but on your worksheet it will all be sorted out. So to determine the concentration of ethanoic acid in vinegar, first of all, I'm going to go with the equation first, just so you know what ethanoic acid looks like. CH3. Oh, that's strange that it does that. Okay. Sorry about this. CH3, and I just want that to be subscript. COOH. We are putting it in a volumetric flask. We are then going to titrate it with barium hydroxide. Okay, so the other reactant is barium hydroxide, which barium has a 2+ charge, hydroxide is 1-, so it's BaOH2. And then our products will be, so it's an acid plus a metal hydroxide, so I'm going to get salt, and it's really annoying to work out this salt. The conjugate base of ethanoic acid is actually ethanoate because it only loses the hydrogen that's part of the carboxyl group. That's the only acidic one there. So it's still monoprotic. So that's 1-. Barium will be 2+. So the acid will be barium, brackets, ethanoate. Notice that actually, it's not a big issue. Okay. Forget that idea. Really, like, look, I'd prefer putting the barium here because that's showing that the barium's attracted to the negative side of the ethanoic acid, but it's really not a huge deal. Anyway, and then the other product is H2O. Okay, so we're going to put our balancing into play here. We've got 2 ethanoic acids to balance off with those 2 ethanoates, and we have 2 waters. Now let's do a flow chart, and I think I might even do free draw just to make it easy for me to draw this flow chart. So to determine the concentration of ethanoic acid in vinegar, a student first diluted 100 ml sample of vinegar to 200 ml in a volumetric flask. So I'm going to draw this out because it takes into account a dilution. So you've got, oh, that won't be the best way to do it. Let's do it on paint, and then we'll bring it back into Word. All right. Just borrow the text so we don't forget. Okay, 100 ml sample of vinegar, so 100 mls. We dilute it to 200 mls. So I'm going to call this a dilution. The student then added 20 mls of this solution to a conical flask. So they've done another manipulation. So 20 mls, that's called an aliquot. And let's just remember what happens during a dilution and an aliquot. So during a dilution, the concentration goes down, but the moles stay the same. During an aliquot, the moles goes down, but the concentration stays the same. This will just really help with your maths that you need to do, your calculations. The student then added, titrated it with 0.1 mole of barium hydroxide, the average titrat. So What's coming out of the burette? That's barium hydroxide. We get a couple of bit of information about barium hydroxide. We get the concentration of barium hydroxide as 0.1 molar. And we get the volume of barium hydroxide as 17.44 mils. That's not mils, this is mils. Okay, so let's get this flow chart back so we can use it in our calculation. Back into Word we go. There we go. All right, so let's start working out the original acid in the vinegar. So basically we're trying to work out the concentration of acid in the 100 mils. So I'll try and keep that in mind. So step number 2 is really working out the moles of the known, which in this case you can see we've got the concentration and the volume of the barium hydroxide. So the known is brackets OH2 close brackets equals C times V, 0.1 times 0.01744 equals 0.001744. Now step 3 is using the mole ratio, work out the moles of the unknown. So just want to make this clear though, we are not working out the moles of the unknown in the original. So I'm just going to write this out. We are working out the number of moles of ethanoic acid that reacts with the barium hydroxide. It's always good to kind of write this out as well. Oh, not sodium hydroxide, barium hydroxide. It's always good to write this out because it allows you to get consequential marks if you make a calculation error. So do I expect more or less of the ethanoic acid? More. How much more? 2 times. So it'll be 2 times the moles of barium hydroxide. And that will be, so 0.001744 by 2 equals I should probably write out the whole thing. 0.003488. Now, step 4 is work out the concentration of your unknown. But actually, let's do that. Yeah. So the concentration of ethanoic acid that reacts with the barium hydroxide equals moles over volume equals this many moles over. Now, which volume are you going to use? Is it the 100 mil, the 200 mil, or the 20 mil? Because they're all the manipulations of the ethanoic acid. If you're thinking the 20 mil, you're right, because that's the volume that actually reacted with the barium hydroxide. So you need to have the moles that reacted with the barium hydroxide divided by the volume that reacted with the barium hydroxide. So you will get 0.1744. So that's the concentration that reacts with the barium hydroxide. Let's have a look to see if it's the concentration in the original. So we've worked out the concentration in here. We know from our flow chart that when we take an aliquot, the concentration stays the same. So the concentration in here will be also 0.1744 moles. But what's the concentration in the 100 mil? Well, it drops from the 100 mil to the 200 mil. So it'll be more. And how many times more? times 2. The other thing you can do if you're not given such nice numbers like 100 and 200 is you can do the dilution formula. So C1, V1, C2, V2. So I'll show you that with this example. So what do we know so far? The concentration of the ethanoic acid in the 200 mils is also 0.1744. And I'm going to do C1, V1, C2, V2 to work out the original. So C1, V1 equals C2, V2. So what's C1? The original concentration is what we don't know. The volume will be 100 mils. The C2 will be equal to 0.1744. And the V2 will equal 200 mils. So simply working out C1 equals C2 times V2, so 200 times 0.1744 divided by 100 equals 0.3488 mole per litre. So this shows you that you could either times it by 2 and get the same answer, or if you're stuck, do C1, V1, C2, V2.